All right, in this example, we're looking at a genetic disorder called Huntington's disease. Huntington's disease is a neurologic disorder that affects the nervous system, particularly the brain. All right, so in this case, Huntington's disease is a dominant disorder, and being unaffected is a recessive disorder. All right, so what that means for our possible genotypes is that if you have Huntington's disease, your genotype can either be homozygous dominant, or it could be heterozygous. All right, if you're unaffected, your genotype is going to be homozygous recessive. All right, so the easiest genotypes to identify are going to be the individuals who are unaffected. Okay, remember the individuals that are unaffected by the trait are not going to be shaded in. So anyone that's not shaded in, we are going to identify them as homozygous recessive. So we know what their genotype is. However, the genotype that we do not know is we do not know what the individuals that are affected by the disease. They can either be homozygous dominant or heterozygous. So how do we figure out which one it is? Well, we look to the offspring, okay? So let's look at this first individual right here, okay? She can either be homozygous dominant or heterozygous. So let's look at her first offspring down here. Her first offspring is homozygous recessive. That means that this individual got one of the recessive alleles from the father, and he must have gotten another recessive allele from the mother. So the mother has to be heterozygous, all right, because she has Huntington's disease. That's where that dominant allele comes from, and she passed on this recessive allele to her offspring. So she has to be heterozygous instead of homozygous dominant. All right, so let me erase this. All right, so we figured out the one. All right, now let's figure out this one right here, this person, okay? This person has Huntington's disease, all right? So that means this person has a dominant allele, all right? That dominant allele had to have come from the mother, okay? So let's look at what the father can give. The father can only give one of his two recessives. So he's going to give that recessive, all right? And that means that this offspring is going to be heterozygous, just like the mother. All right, let me erase this, clean it up a little bit. All right, now let's look to the second generation. Let's look at this individual right here, okay? So we're trying to figure out if this individual is homozygous dominant or heterozygous. So let's once again look to the offspring. Once again, we have a known homozygous recessive offspring here. That means this offspring got one recessive allele from the father, which we knew his genotype. So that means the mother, we know she has one dominant because she has Huntington's disease. She had to have given the recessive allele here. So that means that she is heterozygous for the trait. All right, clean this up. All right, and now we're looking at the last individual. This last individual has Huntington's disease, so they would have at least one dominant allele. All right, that dominant allele came from the mother. All right, and the only other possible allele came from the father, and he only has recessives, so he gave one of his recessives, making this individual heterozygous. All right, so there you go. That's how we use a pedigree to figure out the genotypes for a dominant disorder.